All right, let's see if this works today. I've changed some things around, trying to do some lag. And I'm not going to do number one, but I'm going to do an example like it, okay? Say you had, I don't know, 81 to the 7/8 times 81 to the negative 3/8. All right, two things. I know that x to the a times x to the b is x to the a plus b. With like terms, you add exponents. That's what I do. So I know that 81 and 81 are like, so off to the side, in my brain, I think 7/8 plus a negative 3/8. God bless you if you can't do this, but 7 plus a negative 3 is 4. Leave the denominator alone. It's a half. So this becomes 81 to the half. Now I also know, because I taught you, and you should know too, because we have it in our notes somewhere, that x to the 1/2 is equivalent to the square root of x. So this is the square root of 81, which is 9. If I was solving for algebra, it'd be plus or minus 9. All right, so that's how you do number one. You add exponents. All right, number two. In order to do number two, and I'm going to actually do number two, several properties actually go into play here. I'm going to use the property of ab all to the x is a to the x, b to the x. It's actually the first thing I'm going to do. I like to call it the distributive property of exponents. I'm going to distribute that 3/4 in. There's other ways of doing this, but this is what I'm going to do. A 2 times 3/4 is going to be 3/2. 8 times 3/4 is going to be 12. That's not going to be 12. Am I stupid? It might be. It's going to be 6. Makes more sense. And then 3/4 times 1/3 is going to be 3/12, because we multiply. 3/12 is a quarter. So I look like that. It's kind of bad. All right, now I'm going to think about the property that says x to the a over x to the b is x to the a minus b. I'm just using rules. So, I have to figure out what 3/2 minus a quarter is. Probably make a common denominator. 3/2 is 6/4. And ta-da! 6/4 minus a quarter is 5/4. So this becomes a to the 5/4, b to the 6th. I'm going to glance at something real quick. I think the instruction set was to write this as a radical. I have the problems down, but I forgot to keep the instruction set. Find the reduced radical form of each expression. Yes, it is. All right, well, b to the 6th doesn't require a radical. B to the 6th is simply b to the 6th. 5/4 is going to be the 5th root of a to the 4th. Now that comes from the idea that x to the power over the root is the root of x to the power. X to the p over r. Yeah, they're not too bad. All right. 3 is pretty easy. I think it is. That's also me. Turns out you can take the 4th root of 1024. Well, let me take that back. You can't take the 4th root of 1024. 4th root of 1024 would be 256 times 4. See, 1024 is 4 times 4 times 4 times 4 times 4. 4 to the 5th. And that's probably how I should write it. So let me rewrite that. This is the fourth root of 4 to the fifth, x to the ninth, y to the 12th. Now all I have to do is I have to ask myself how many times the root enters the exponent. So 4 enters 5 one time, so there's one 4 out front, and there's a 4 left inside. 4 enters 9 twice, x squared out front, and now there's now 1 left over. 4 enters 12 3 times. That's all gone. Whoops. Click the button. So here's what I have left. I have a single 4, I have a single x, and there's no y. Hey, that wasn't so bad. 4 is kind of a rough problem. You're asking to take the cubic root of 4 over nm squared. Now, first thing I'm going to do is I'm going to break this radical up as the cubic root of 4 over the cubic root of nm squared. Now, it is not proper to have a radical in the denominator. So I'm going to do something silly, and I'm going to multiply the top and bottom by the cubic root of 3m. Because of the desired outcome that happens. So a cubic root of 4 times a cubic root of 3m is a cubic root of 12m. There's nothing you can do with that. But the bottom becomes the cubic root of 27m cubed. That is evaluatable. So the top stays the cubic root of 12m. This is where a lot of kids struggle. They're like, man, I'm good at math. I'm good at math. I have no idea what you just did. Because you don't know cubes. Cubic root of 27 is 3. Cubic root of m cubed is m. But I've watched a lot of kids who think they were smart get destroyed by this concept. Because you're not good with numbers. You're a button pusher. That's what you are. It's what you is. Be better than pushing buttons. All right, moving on to 6. Maybe y'all will figure some of this stuff out yourself. It's just the distributive property. I mean, it's not that hard. Square root of 5 times 6 is simply 6 root 5. Square root of 5 times 2 is root 10. I mean, if you don't understand that, you don't know what 5 times 2 is. You don't. It's bad. Do better. What's worth doing on here? Probably 8. We're going to use the conjugate. And the conjugate of root 5 plus 3 is negative root 5 plus 3. That's what she is. The weird thing changes sign. I'm going to rewrite that as 3 minus root 5 just because I like negative symbols in a certain spot. And I'm going to crank out the math. The nice thing about using the conjugate, it's an a squared minus b squared pattern. I don't know if that makes any sense, but the only thing that matters is the first and the last. Whenever you use a conjugate, it's just first and last. The bottom is going to become root 5 times negative root 5, which is negative 5. And 3 times 3, which is positive 9, which ends up being 4. The top, we use the distributive property. We'll have 3 times root 7, which is 3 root 7. And a negative root of 5 times root 7, which is negative root 35, because 5 times 7 is 35. And there's not really anything you can do with that. It doesn't simplify. So 3 root 7 minus root 35. My final pretty answer. And I'm done with that slide. Moving forward. I want the reduced radical form of each equation. So I want a radical when everything's said and done. These are so simple. Look at 11. First thing I would do is I would distribute that 2 to everything, including the 3. 2b to the 1/2. 3 squared is 9. A half times 2 is 1. Let me switch over to upper cases because my lower cases look like 6's. Three squared again is 9. 2 times 1 is 1, so just a b. 2 times a third is 2/3. And now I can just multiply through. This isn't the distributive property because there's a multiplier symbol in there. All right, so I'm just going to kind of link these two pieces together. Actually, I can't. They have differing exponents. Or I can actually. Those are like terms. 2 and 9 are alike. I'm actually multiplying 2 and 9. That's 18. Now, when I think about b to the half times b, b has an understood 1 as an exponent. So the result has to be b to the 1/2 plus a 1, which is b to the 3/2. Then we have this c to the 2/3 just sitting there all by herself. Now the deal here was radicals. So again, we're using this whole idea of x to the p over r is the rth root of x to the p, and I can rewrite things. That's how it works. 18 doesn't have a radical. It won't be in a radical. b is going to have a root of 2, which is understood, cubed. By the way, that little guy right there, it's this funny word in math that we call understood. You're not supposed to write it. You're just not supposed to. But whatever. If I don't write it, I don't know. Then we have c, which is a cubic root, and c is squared. It's not a hard little thing to do, and that's all I'm going to do with this. Let's see here. I'm going to leave 18. Yeah. I definitely want you to try. You need to try. I kind of like things like 19. I don't know why I like these, but I do. Cubic roots, simplification. So let me think about the cubic root of 81. 81, and here's the problem with mathematics, is that kids don't understand numbers, is 27 times 3. And the cubic root of 27 is 3. So that 81 became 3 cubic roots of 3. There's already a 4 there. We have 4 times 3 cubic roots of 3. Now we're going to look at root 72, and that is also a cubic root. Probably going to be, well, that's interesting. We need a 3 in there, don't we? It's 24 times 3. Lost my place. We're not going to be able to get too far with that one. I'm having a bit of a brain fart here, but 72 is going to be 8 times 9. And the cubic root of 8 is 2. So 2 cubic roots of 9. We have some things here that aren't going to be able to be put together. That's just the way this one is. There's already a 2 out front. And then I found that to be 2 cubic roots of 9. And then I have minus the cubic root of 24. So thinking about cubic root of 24, it is the cubic root of 8 times 3, and the cubic root of 8 is 2. So there's only two things up here that are alike. There's this guy and that guy. Now this guy, of course, being 12 cubic roots of 3. And we're going to take away from it 2 cubic roots of 3. And then we have this piece right here, minus 4 cubic roots of 9. 12 minus 2 is 10. And that's as far as you can take it, because these are not alike. You can only add or subtract like terms. All right, so move on to 21 here. 21 simply the DD property. 4m times 4m is going to be 16m squared. 4m times a negative root 3 is negative 4 root 3m. Kind of funny looking. Negative root 3 times 4m is also negative 4 root 3m. And then negative root 3 times a negative root 3 is going to be plus 3. Because if you multiply a radical by herself, you get the number inside. And we get 16m squared minus 8 root 3m, because negative 4 is negative 8. And we get a plus of 3. So it's not too bad. I don't think it's too bad. I'm not going to do 22. I'm not going to do 23. Wish I had another one that looked like 26. 26 again is use conjugate. The conjugate of 3 plus root x is going to be 3 minus root x. That's what she's going to be. We'll distribute up top. Negative 6x plus 2 root x. Down low, since it's a conjugate, we do first and we do last. 3 times 3 is 9. Root x times root x is going to be x, but positive times negative is negative. And that's it. Oh, no, it's not. I made a mistake. It's right there. That's the mistake I made. You could see somebody be really tricky. Like a good test taker or a good test maker might rewrite 2x root x as 2 root x squared, x cubed. Those are the same thing. They might do that. But I'm going to stop there. That's as far as I personally would take it. And there's one more page. 28. The interest rate R required to increase your investment P to an amount A in M months is found by R equals A over P raised to the 1 over M minus 1. What interest rate would be required to increase your investment of 3,600 to 6,400? So your investment is P, and you're going to increase it to some amount A, and there's your M. So R has to be 3,600 over 6,400 raised to the 1 over 7, because M is 7, minus 1. And from there you just crank out the math. Where's my keypad? Let's see, what did I have here? I had, in a set of parentheses, 3,600 over 6,400 times divided by, it's early, forgive me. She was raised to the 1/7 power, and then I took away 1. It's going to be a pretty impressive rate. I did it backwards, didn't I? What did I write? Way to go, math teacher. There we go. I knew I did it backwards because I had a negative interest rate. So let me fix that real quick. You'll notice my pen is not lagging today. I went and got an SD card, and I am using that to hold on to my video as opposed to my laptop's hard drive, and things aren't lagging anymore. All right, that's a monthly interest rate, isn't it? Almost 9%. That seems reasonable. That's per month. So it says nearest tenth of a percent. This is the decimal 0.0857. Oh. I was just complimenting it. 0.0857. Now it's going to do this to me. To convert to a percent, you take your decimal and you move it twice. Now they want nearest tenth of a percent. So 8. You heard it. I literally was complimenting it, and it did this stuff to me. 8.6%. Thankfully, this was the last one I had to do. So, done with it for today, for now.